So dear student, let us see question number 14. It is x into root of 1 plus x plus y into root of 1 plus x is equal to 0. Then we have to prove that dy upon dx is equal to minus 1 upon 1 plus x square, and the value of x should be between minus 1 to 1. Then only the function is defined. So let us see this question. It is given to us. So now if you use the if you directly differentiate it, then it becomes somewhat complicated, because here we have to use the product rule, here also we have to use product rule. So I will suggest to you, before differentiation we will simplify this question. So transfer this term to that side, so it will become x root of 1 plus y equal to minus y root of 1 plus x. So now we will take square of both sides. So squaring both sides, the square of x, it is x square. The square of 1 plus y will give you 1 plus y equal to the square of minus y is a positive y square, and it is 1 plus x. Now we will multiply, so it becomes x square plus x square y equal to y square plus x y square. Now we will transfer all the terms to the left hand side, so it is x square plus y square so we will take x plus y plus xy equal to 0. So it is x plus y plus xy equal to 0. From here we will transfer this x to right hand side, and we will take x common from here. So it is 1 plus x is equal to, we have transferred this x to this side, so it becomes minus x. So y is equal to minus x upon 1 plus x. Now we can use here quotient rule. Now we can differentiate it. So it is dy upon dx is equal to denominator as it is differentiation of numerator minus denominator as numerator as it is differentiation of denominator. So it will be differentiation of 1 is 0 and it is 1, and upon square of denominator equal to minus 1 minus x minus minus plus x upon 1 plus x square. So this will give us minus and minus cancel, so we are left with minus 1 upon 1 plus x whole square. So this is the value of dy upon dx. So hence dy upon dx is equal to minus 1 upon 1 plus x whole square. So now let us see question number 15. If x minus a whole square plus y minus b whole square equal to c square. So this is the given relation. For some c which is a positive number, then we have to prove that 1 plus dy upon dx square whole to the power 3 upon 2 whole upon d square y upon dx square is a constant term or constant independent of a and b. It means that we will find, when we will solve this part, then the final answer, the final solution should not contain any term that contains a and b. Means it should be free from this the solution of this part should be free from a and b. इसमें कोई भी ऐसी टर्म नहीं होना चाहिए जिसमें a और b होना चाहिए. अगर a और b हो गई, इसका मतलब ये वाला जो पार्ट है ये टोटली डिपेंड करता है a या b पर. So let us see here x minus a. So I have written here, instead of dy upon dx I have written here y1, and instead of d square y upon dx square I have written here y2. It does not make any difference. So see here, first of all I will differentiate it once. So it is 2 into x minus a, then the differentiation of x minus it is 1 plus, now I will differentiate this part, so 2 into y minus b, and the differentiation of y it is y1 equal to, since c is constant term here, so the differentiation will be 0. So now from here I will find the value of y1. So y1 will be equal to, this part will be transferred to this side, so it will become minus 2 into x minus a, and since it is in multiplication, so it will be in divide. So y into x minus y, 2 and 2 cancelled out, so we are left with y1 is equal to minus x minus a and y minus b. So it is the differentiation for the first time. Now we have to differentiate it twice. Now dear students, either you can use your quotient rule, or instead of using quotient rule I will suggest you to write it like this. So this will make the calculation very simple. So y minus b can be written as y minus b to the power minus 1. Now we will differentiate it. Since it is the product of two functions, so we will use multiplication rule. So it will be y2 is equal to minus first function as it is differentiation of second function, so it will be y minus b minus 1, it will be minus 2, and minus will come. See here, this is, let us suppose this is x to the power minus 1 is minus 1 into minus 1 minus 1, so it becomes minus 2, plus second function as it is, and differentiation of first function, so the differentiation of x is 1 minus 0, it is 1, or y2 equal to minus, it is x minus a. Dear students, here we will differentiate y also, and the differentiation of y is, sorry, y1. I repeat, x minus a as it is, differentiation of y minus b to the power minus 1, it is y minus b to the power minus 1, it is minus 1 into y minus b n minus 1, so minus 1 minus 1, so it is minus 2. Now we have to differentiate y also, so the differentiation of y is y1, and plus first second function as it is, differentiation of first function, that is 1. So minus of x minus a, y minus b to the power minus 2, so this can be written as y minus b whole square, power will be positive, into, now the value of y1, it is minus x minus a and y minus b, plus we have substituted the value of y1 from here to here, plus this can be written as 1 upon y minus b. So now let us see here, minus into minus, it is plus, x minus a into x minus a is x minus a whole square, and y minus b whole square into y minus b is y minus b whole cube, plus 1 upon y minus b. Now students, we will take LCM. So here minus, LCM will be y minus b whole cube, so it is x minus a whole square, plus since y minus b is here, so LCM will be, also the answer will be x minus, so y minus b whole square, whole upon y minus b whole cube. So this is the value of y2. So dear students, y2 is equal to minus, here we can see that x minus a whole square plus y minus b whole square, x minus a whole square plus y minus b whole square equal to c square. So we can replace the numerator part by c square, so it is c square upon y minus b whole cube. So here this is the value of y2. Now we will put these values the value of y1 and the value of y2 in the given relation. So let us see the given relation. So now let us say here this is the given relation. So 1 plus dy upon dx. So the value of dy upon dx is, that is y1 is minus x minus a upon x minus b. So I have substituted this value here, minus x minus a y minus b whole square, and the value of y2, is minus c square upon y minus b whole cube. So here I have replaced this d square y upon dx square with minus c square upon y minus b whole cube. Now let us simplify it. So I will take LCM. So LCM will be y minus b whole square, and it will come here. So y minus b whole square plus the square of minus is positive sign, so it will be x minus a whole square all upon y minus b whole square to the power 3 upon 2, and see the denominator part I can write here as y minus b whole cube upon minus c square. Now again see here x minus a whole square plus y minus b whole square, x minus a square plus y minus b whole square is c square. So I will replace this term by the numerator by c square, then y minus b whole square to the power 3 upon 2 into y minus b whole cube upon minus c square. Now dear students, this can be written as, be careful, so y minus b, it is whole square into 3 upon 2 into y minus b whole cube upon minus c square. So square and square means these two and two will cancelled out, so we are left with c cube upon y minus b whole cube into y minus b whole cube upon minus c square. So it will be cancelled out, so c cube and minus c square will be cancelled out, so we are left with a c upon minus 1, that is minus c. So the answer of this one is minus c, so it does not contain any term that contains a or b. It means that it is independent of a and b. So let us see question number 16. Cos y equal to x cos of a plus y, and we have to prove that y1 is equal to cos square a plus y upon sin a. So now first of all we will differentiate both the sides. So the differentiation of cos y is minus sin y, and the differentiation of y is y1 equal to first function and second function. So first function as it is, differentiation of second function. So the differentiation of cos x is minus sin a plus y, and the differentiation of this a is 0 and y is y1, plus second function as it is, and we have to differentiate x, it is 1. Now we will transfer this term containing y1 to that side, so it is of minus, so it will become plus. So sin a plus y minus sin y, and we have taken y1, x is also here, so x minus, so it becomes plus sin a plus y minus sin y, and we have taken y1 common. It is equal to cos of a plus y. Now dear students, we see here we don't want x, So from here we can get the value of x. So the value of x is cos y upon cos a plus y sin a plus y minus sin y into y1 is equal to cos of a plus y. We will take LCM, so the LCM is cos a plus y. So it will become cos y, or I can write the term of sin first. So sin a plus y into cos y minus sin y cos of a plus y. I have taken just LCM, so it is upon 1, so it will be multiplied whole upon cos a plus y. It is y1 is equal to cos a plus y. So now dear students, in the lower classes, in the class 11th, you have studied this formula that sin a cos b minus cos a sin b. This is the formula of sin a minus b. So sin a cos b minus cos a sin b is equal to sin a minus b. So we will use this formula here. So it will become sin a means a plus y minus y upon cos a plus y into y1 is equal to cos a plus y. So y and y cancelled out, so we are left with sin a upon cos a plus y, y1 equal to cos of a plus y. We will transfer this, we will get the value of y1. So y1 is equal to cos into cos, it is cos square a plus y upon sin a. So this is our required solution.